Good morning, student. Last lecture we discussed crystalline solid and amorphous solid, and again classification of solid. Now next topic is crystal lattice and space lattice. What do you mean by crystal lattice and space lattice? That means arrangement of particles, arrangement of constituent particles in one dimension, otherwise two dimension or three dimension. Suppose like this. This is arrangement of particles in one dimension. Like this. This is arrangement of particles in two dimension, one dimension, two dimension. Again, this type of arrangement is possible in three dimension also. So when three dimension we draw the arrangement, different arrangement, then it is known as crystal lattice. Here two dimension, different arrangement is possible. Again like this. This type of arrangement, that means different types of arrangement are possible. So what they mean by crystal lattice? That means one type of arrangement. So such definition, such an arrangement of constituent particles like atom, ion, molecule. Arrangement of constituent particles, atom, ion or molecule in three dimensions is called crystal lattice, otherwise space lattice. This type of arrangement will be regular in two dimension, like this is rectangle shape, square shape, rhombus, parallelogram. That means different types of shape are produced. That means crystal lattice means such a regular arrangement of constituent particles in three dimensions is called crystal lattice. This is known as lattice point. That means characteristic of crystal lattice or space lattice is first, each point in crystal lattice indicate constituent particles. These may be atom, ions or molecules. Second, each point in crystal lattice is called lattice point or lattice site. So this is lattice point, otherwise lattice site. To obtain the regular shape, these lattice points are joined by straight line. Here joined by straight line. That means rectangle shape is obtained. Again here rectangle shape. So different two-dimensional shape is obtained. Here we study in 3 dimensions. That means each point joined by straight line. To obtain complete shape of crystal lattice. So again, regular arrangement of constituent particles in 3 dimensions is called crystal lattice. Each point in a crystal lattice indicates constituent particle. This may be atom, ions or molecule. Each point in a crystal lattice is called lattice point or lattice site. Each point joined by a straight line to obtain complete shape of crystal lattice. In 3 dimensions, also we draw the crystal lattice like this by arranging suppose these are the lattice point, like this. We join by straight line. Then crystal lattice is obtained in 3 dimensions. That means here cube is obtained. Simple cube. Again, repetition is carried out in 3 dimensions. When repetition is carried out, three-dimensional crystal lattice, otherwise space lattice. Now, from there, if we want to study the crystal lattice, otherwise space lattice, then there is no requirement to study the entire crystal lattice, just the repeating portion. So here we can see this is repeating portion. This is repeating portion. This is repeating portion. It is repeated. So this repeating portion is known as the unit cell. The next point is what do you mean by unit cell? So definition of unit cell is what? Unit cell. The definition of unit cell. smallest portion of three-dimensional crystal lattice, which when repeated in different direction over and again, then entire crystal is obtained. This smallest portion. So this smallest portion is called unit cell. Okay, which is repeated in three dimensions. In two dimension also unit cell is possible. This is two dimension arrangement. So here unit cell is rectangle. This type of also arrangement is possible. Parallelogram, rhombus, square. This is also repeating pattern. Generally we study in three dimension. So in three dimension, definition of unit cell is like this. How to identify, otherwise how to characterize the unit cell. In two dimension only two parameters are required. If we study in three dimension, then how to characterize, otherwise how to identify. So for that, in three dimension, 6 parameters are required. 6 parameters. What are 6 parameters? Three dimension, one unit cell. So this is A, that means similar to LDH. A, this is B, and height is C. Okay. So three parameters are length, width, and height. That means A, B, and C. Okay. Now different angles are required. That means alpha, beta, and gamma. Alpha, beta, and gamma. Now, actually, what is system? Which angle is alpha? Here, this is A. Again, A. Now, this is B. This is C. Again, this will be C. So remember, A, B, C, alpha, beta, and gamma. So between A and B, angle is gamma. So between A and B, angle is gamma. So this is A, again B, so this is gamma angle. Okay. Similarly, between B and C, angle is alpha. So between B and C, this angle is alpha. Now again, between C and A, the remaining is beta. So this angle is beta. That means 6 parameters are required to characterize the unit cell in 3 dimensions. And generally we study in 3 dimensions. So by 6 parameters, we can identify the unit cell. Alpha, beta, gamma, A, B, C. Now different types of unit cells are available. So we classify unit cell into 2 categories. So next topic is classification of unit cell. So I hope definition of unit cell will be clear. Again, I am repeating, the smallest portion of 3-dimensional crystal lattice, which when repeated in different direction over and again, then entire crystal is obtained. That means, if we study the unit cell, then it is similar to the study of crystal lattice, otherwise entire crystal. So types of unit cell. So any unit cell in 3 dimensions can be classified into 2 categories. So primitive unit cell and second one is center unit cell. So unit cell classified into two categories: primitive unit cell and second one is center unit cell. Okay. Primitive unit cell means what? This is simple unit cell, big unit cell. Constituent particles are present at corners. These are 8 corners on which constituent particles are present. The particles are present at corners only. Corners only. Here, how many lattice points is required for 8? 8 constituent particles are there and they are present at corners only. This is known as the primitive unit cell. Now center unit cell. Center unit cell having 3 types. First one is body center. Body center unit cell, otherwise BCC. Face center unit cell, otherwise FCC, and center unit cell. There is no short name. The body center unit cell, face center unit cell, and center unit cell. So which type of arrangement are there? Center unit cell means constituent particles are present at corners plus at additional site. First, we are putting constituent particles at corners. In each case, constituent particles are present at corners. Here also corners. In each case, constituent particles are present at corners. Here also at corners. Plus additional constituent particles are present. Now body center, that means corners plus additional site. Here additional site is body center. That means center of this cubic unit cell. That means here. That means one extra lattice point, otherwise particles is required, which is at body center. Therefore, it is known as body center unit cell. In case of face center, additional constituent particles are present at face center. That means face center means this cubic unit cell having 6 faces: left side, right side, top, bottom, front and back side. That means this is left side, right side, top, here bottom, front side and back side. That means additional constituent particles are present at the center of each faces. Here body center, now corners plus at the center of each faces. That means lattice point are 8 plus 6. 8 corners plus 6 at the center of each face. Now in case of end center, corners are present plus additional. At which position additional constituent particles are present? At the center of any two opposite faces. Again remember, at the center of any two opposite faces. That means top and bottom, otherwise left and right side, otherwise front face and back face. Any two opposite faces. At the center, here we select top face and bottom face. That means 8 plus 2, additional 2 constituent particles are there. This is known as end center unit cell. That means unit cell, 2 types: primitive unit cell, center unit cell. Finally remember, primitive unit cell means constituent particles are present at corners only. And here additional side, corners plus additional side. Body center, then at body center 1 constituent particles, face center, then at the center of each faces, and center, and then at the center of any two opposite faces. Okay, clear? So this will be clear types of